Hello and welcome back. Today we're gonna have a look at two spectrum analyzers. I have two big boxes here. It's from the brand UNI-T and it was sent to me by UNI-T Europe. They are borrows, but we have a chance to have a look at them. We have one from the UTS1000 series and we have one from the UTS3000 series. Both have a tracking generator. So let's have a look. Out of the box, they look pretty similar. This is the 1000 series, goes up to 1.5 gigahertz, and this one goes up to 8.4. Wow. Here we have the 1000 series. Looks pretty cool. It has a tracking generator, this version, because it is the T. And we can play a little bit with filters. It feels all very strong. This is not a cheap plastic. I think you can replace the dust filter, so that is nice if you operate in a dusty environment. We have 10 MHz in, 10 MHz out. We have a trigger in, even HDMI, a LAN port and USB. So the front looks exactly the same as the other one, only of course the 3000 versions have different specs. But they decided to use the same casing. I think it's a little bit more heavy, but only slightly. Same here. It's exactly the same. 10 MHz in, 10 MHz out, trigger, HDMI, LAN, USB. The UTS1000 is available in two versions. One is the 1.5 GHz version, which we have here, and there is also a 3.2 GHz version, both optional with or without the tracking generator. The 3000 series is available in three versions. It's the 2.1, the 3.6 and the 8.4 GHz version that we have here, also optional with tracking generator. The biggest difference between the 1000 and the 3000 is the resolution bandwidth. For the 1000 is 1 Hz up to 1 MHz, while the 3000 is 1 Hz up to 3 MHz. Also the measuring points is 10,000 for the 1000 and 40,000 for the 3000, which is quite impressive. Also the 1000 series has 4 traces, while the 3000 can do 6 traces. When we look at the noise floor, it's quite impressive because it is minus 161 dBm, and you find that usually on the higher models, but I was actually surprised that they specified that also for the 1000 series. So they look the same from the outside, they have the same noise floor. The 3000 of course has more scanning points and more traces they can do at the same time. So is there inside a different processor? Because I couldn't find anything about speed. So let's just start them up at the same time and let's see. Before I start, I will reset them both to factory defaults. I will clear all data just to be sure another user didn't mix things up. And now it is in Chinese. And the thing that I find sort of smart is, even though it's all Chinese, the word settings is still in English. Then language is still in English, even though the rest is all in Chinese. So as a non-Chinese user, you can still easily change everything. Pretty smart. Yeah, when we look from the left to the right, you can clearly see that the model on the right has a lot faster scan. You can see the updates on the display a lot faster. So that the casing is the same doesn't mean the whole platform is the same for sure, and there some bigger processing going on. Look at this scan. And then look at the updates of this one. So it has touchscreen, it's also pretty cool. 1 MHz. So it is doing now a full scan from 1 to 8.4 gig. And look how fast it updates. And then back to this one, also doing a full from 1 MHz to its 1.5 max. You can see the updates are slower. Okay, let's do a test with the auto button. I always like this auto tune or auto setup that you also have on your oscilloscope. This is great. I'm not a real advanced user of spectrum analyzers, but this button is great. So let's put the signal on both of them and let's see how fast both can detect it. I will put on both a 10 MHz signal from my distribution amplifier 0 dB, so that should not be a problem. We can see it's a square wave, so we do have some harmonics. Let's do the auto button. 1, 2, 3. Look at that, they're on the right. It's super fast. Well, this is just my trigger amplifier that I use because it's cheaper and I can distribute in different frequencies, but you can see it is a square and a square really gets you a lot of harmonics. So let me get the proper distribution amplifier. I have here one that has on all the outputs has a 10 MHz bandpass filter, so this signal will be a lot cleaner, and maybe the detection of the auto system is then also faster. Okay, the signal is now very clean sine wave, and do this again. Auto. You can also see that all the harmonics were gone. Yeah, this one detects so much faster. This processing here is crazy. Well, these demo units still have all the licenses activated, the advanced measurement mode also, so that is very interesting to play a little bit with that. So let's say we do again the start frequency at 1 MHz and the end 1000, and we can see that the signal is super clear. There are no harmonics. So let's go back to the square wave. Okay, I will just replace the square wave distribution amplifier. I have a video about the exact difference between these two, but here is already a very big example of how this is different. Here you can see all the harmonics coming in the screen, and that is because of there is no bandpass in these, but you can use it for different frequencies, not only for 10. That's why these are called trigger amplifiers or square wave amplifiers, and this is really a 10 MHz. So let's play a little bit with this advanced measurement. And what I like to use a lot also on my Sigland is this harmonics display. So if you do auto tune, okay, it clearly found it. I have my marker. Go to the measurement menu, harmonics, and then, okay, well, somehow it didn't get it, so I will say, okay, I want the 10 MHz, I want the first 5, and then it will tell you exactly how much it is suppressed. Oh, let's do the same here. Auto, it detected it. Measurement, harmonics. Okay, also it lost the fundamental, but we were doing 10 MHz and we want at least 5. This would be a nice default, by the way, to see at least 5, and this one is a lot faster. The speed of the 3000 is really amazing. If I just start typing here how fast it draws, and I have all my amplitudes here from all 10. If I do the same here, wow, the 3000 is super fast, and I already was scratching my head a little bit because I have a Sigland myself, and the 3000 was so amazingly fast that I thought, oh my god, I like this machine way too much. But it is a different pricing for sure. But when I compare it to the 1000 series, it is more or less the same, and the pricing is also the same. So I'm kind of so what else we find in the measurement menu? We have channel power, UNI-T power. Not sure what it is. Occupied bandwidth. It's fast. TOI. Well, I'm not a real advanced user. I'm not necessarily know what this is. But you can get a lot of stuff out of it. And of course the Spectrum monitor. That looks pretty cool. And I see there are even tricks because you can just push here also in the top. And then you can even change the impedance. It says 50 ohms here, but here you apparently can change it to 75 or back to 50. You have an automatic attenuator, or you do that manual, and for lower signals you can put your preamp on. And all the screens you can maximize as well if you want. Look at that huge screen. Well, everything works a little bit as you expected. I haven't read any manual and I actually can control it and get what I want. Now I like to see how the tracking generator works. I have a little 10 MHz bandpass filter, so let's see what we find. It is a 10 MHz, so my start frequency is 1 MHz, then stop frequency, let's say 40 MHz. Okay, what you usually do with the tracking generator is that you normalize it, because we have some losses in the cables I have here. So I want to be as close as possible to what I have. So if I go to tracking generator, I can set the tracking generator on, and it will measure already something, and it is now minus 70, so I will put a 0 dB, and then I will normalize my cables. So you can see the line is not completely straight. We can see that here. That can be the loss of the cable or the internal circuit. So what we do here, we normalize it to get a sort of a 0 measurement, like a relative mode of a multimeter, but then a little bit more advanced over the spectrum. And here we see now it's exactly 0. So instead, now we have a nice 0 line. And then here we go. Yeah, it's very nice. So here we can see there is a lot of attenuation below the 10 MHz, and here we come in the 10 MHz. Can I put a marker here? Marker frequency, put that to 10. Okay, so here we are at 10 MHz, and here you see the attenuation is almost like 0. And then the cable is already taken from it because of the normalizing. And outside, to suppress all the harmonics, you can see it is 35 dB in the minus or even more. Let's see if we do a higher frequency. Stop frequency, let's say 100. How is it there? Yeah, look at that. The suppression of the harmonics is amazing with this filter. It really passes only the 10 MHz. So it's got HDMI output also, so let's see how that works. I switched everything off. I got my screen for my PC. It's quite big, 23 inches, 24 even. So that would be pretty cool if that works. Plug in the HDMI. Switch the power on. Does it work immediately, or we need to switch something on? Let's have a look. Wow, this is crazy. Look at that huge screen. It still responds fast. What can we do here? Spectrum monitor. Yeah, look at that. On the big screen. And even if we do bigger, wow. I saw it also as a LAN port, so let's see if it has a web interface or it only works with the normal software. Let's just connect the LAN port just to see if how that works. I have a connection right here, and I will connect it in the back. Click. Okay, do we see somewhere on the screen if we have a connection or not? Edit. We have somewhere the network. HDMI was on, network was on. DHCP is not on. Do we get a number? Yes. It's terrible to read, but it is 202. So let me check that on the computer. Okay, let's see. 192.168, 202. Do we have a web interface here? No. This is the first time I actually needed to get the manual to see. They have port 9000 instead of the normal port. So let's see if that works then. And yes, now we are looking in the device. We can see the model. Yes, we know that. Instrument control. Okay, what is this? We need to log in and password, but I found if you scroll up, it says here admin and UNI-T. So let's try that. Okay, so it says admin, UNI-T. Yes, we have indeed. Okay, that's quite cool. We're controlling here the auto tune. Whoop. Yeah, let's do 30 megahertz. Okay, pretty cool. We see an harmonic here. Well, the LAN config is a bit SPI. Yeah, there it is. I downloaded the software. Okay, it seems it's just waiting in the screen. I see no instructions. Of course, I didn't read the instructions also. But I think if you right click, you can here say open SA. So now it's starting the application, it says. Oh, wow. It is a little bit like the web interface, only then you see something on the screen. So, okay, this looks good now. I unlocked the touch lock here, but I think the screen recording software is just now interfering. When it's not recording, I can sort of control. It's not that fast, but it works. But now when the screen recording is running it, I cannot show it to you. What about USB? We see 3 ports here. One is probably to update the firmware, and let's see. Is it detected? Yes, it says here information. Okay, what if we push this? Looks like a screen dump button. If we push that, yeah, it's saving to U-disk, it says. Can I push here? No, I don't think so. This is a USB thing, so you can probably... Okay, that's just the information screen. There is a file manager here, local disk. Can I change here to USB? I put already from the power supply, but I have something here. Open, screenshot. Yeah, there are screenshots. Can I recall the screenshot? Yes, I can. Oh, cool. Whole file manager in it. Okay, we saw the measurement menu, and there is also here a mode menu. In the mode menu we have spectrum analyzer, we have the electric magnetic interference. You need the special probes, and then you can measure the distortion. It's optional, but it works now for 160 hours. And we have the analog demodulation, and that we can do the AM or FM. Let's put FM. Let's see how that works. So I have set up the Marconi signal 100 MHz minus 10 dB, 20 dBm, modulation of 1 kHz, and a deviation of 1.5. So we have the signal 100 MHz, and well, instead of minus 20, it says here minus 35. I don't see any attenuation, so I don't know why it doesn't match up, but let's go to the demodulation, and it lost the center frequency, so let's start that again. That was 100, and what do we see? Can I change a little bit? I need to go, if I go to AM, it does demodulate, and it says 1 kHz. I don't know why it doesn't work on FM. I am in FM mode. So we can see here the carrier. We can see here it's 1 kHz. So if I change it on the Marconi, setting it to 2 kHz right now, and here we have it. It measures indeed the 2 kHz. Maybe if we put a headphone, we can hear something. So that was a quick hands-on of the UNI-T UTS1000 and 3000 series. UNI-T, thank you for the borrow. You, thank you for watching, and I hope to see you next time.